All right, in the second part, I will explain how to plot lines on linear structures on a stereographic projection. So we will need same base image. So this is the um, base image for uh, cut this first part. Okay, in the second part, I will explain how we can plot linear features. It can be a full slicker line or mineral stretching lineation. This type of linear structures will plot as points on stereographic projection. So for um, before starting, we should mark directions on the stairmate. And now we will put or overlay this tracing paper again. And for tracing paper, we should mark directions on tracing paper as well. I always mark 4 directions. That way I can make sure when I rotate tracing paper, I'm not uh, having too much error. Now we are all set. We can plot a linear feature. So linear measurements will be starting with basically 2-digit number, that's the plunge, and a 3-digit number, which is second part, and that's the trend. Why we switch order of 2-digit versus 3-digit numbers with in comparison planes? Let me write down one measurement here. So let's make it 40 degrees plunge, 128 degrees trend. So the reason to switch 2-digit, 3-digit for lines versus planes, we don't want to mix up those measurements. Let's say you collected a lot of measurements in the field and you forgot to label each one of them. In that case, if you record lines and planes in the same order and same nomenclature, then it is most likely that some of the measurements will be just mixed up and you will not know which one was linear or which one was a planar measurement. If we record lines and planes differently like this, in this case, when you look at the measurement, because it starts with 2-digit number, you can automatically say, oh, this is a linear measurement. So the first part should be plunge and second part should be trend. The trend of the line is similar to the strike of a bed, or trend is the bearing of the structure with respect to north. And it's measured on a horizontal plane. So on the horizontal plane, we have uh, from 0 to 360-degree angle as possibility of trend. And for plunge, that's the inclination of the line. If I hold this pen, marker pen, uh, at 90 degrees to this desk, now it is a vertical line. It is a vertical line. And if I hold it parallel to desk, it is now a horizontal, non-plunging line. If I tilt it a little bit in one direction, now it is plunging into desk, and there is an angle between desk and plane, or there is an angle between this plane and this pen and horizontal surface. So that's the plunge or inclination of the line. And so in the same trend direction, 2 possible plunge directions are um, can be measured, recorded. So this one is plunging to the northwest direction, and this one is plunging to southeast direction. In this case, whatever is the trend of line, if it's trending northwest southeast, possible plunge direction is also northwest southeast. In planes, for planes, uh, strike and dip direction is always perpendicular. So whatever is the strike orientation, dip direction will be at 90 degrees to that direction. It will be right adjacent with a quadrant. Okay, going back to this example, now we have this measurement 40 degrees, that's plunge, 128, that's the trend. In trend and strike, those horizontal angles will be always plotted here on the primitive circle. In plunge for lines or dip for bedding planes or planar structures will be countered by these great circles. So let's plot first 128 trend on this primitive circle. Start from north where we have 0, 0, 0 azimuth and count 128 degrees clockwise. Right here, if we count these thick lines, at this point we are at 0, 90, and I will continue from here. So here we are at 100, 110, 120, and after 120 I will count 8 degrees. So I will use 2-degree intervals. So this is 122, 124, 126, 128. I will mark this point. That's 128. This is the trend of the line. Now I will plot plunge. So plunge is 40 degrees. Which direction I should rotate this tracing paper and move this point? Is it supposed to be east or south? Like I explained earlier, we record um, a trend of a line in azimuth in down plunge direction. So that means if we have a trend of this line at 128 in this quadrant, it should be plunging this way to the southeast direction. Otherwise, we would record this direction from other end of the same line. So in this case, it is a southeast plunging structure. If that's the case, you can move this point to either one of these directions, east or south. Doesn't really matter. So let's move it to the south, and we will count 40 degrees in this direction along this north-south reference line. Remember, for dip angle of bearing plane, we used east-west equator line. Now I will use this direction. So it's 40 degrees. Here we are at 10 degrees, 20 degrees, 30 degrees, and 40 degrees. Because lines will be just single points, just points on the stereographic projection. So this measurement will make just a single point on the stereonet, and it will be 40 degrees plunge uh, if you count 40 degrees from the circle towards center of the projection. If we did this correctly, now this point should appear in southeast quadrant because that's the plunge direction. If you remember from this example, if this is the projection, now we have a pencil plunging in this direction to the southeast, and this marker pen should make a mark here in southeast quadrant, not the other one. If it plunges this way to the northwest in the same trend orientation, then it will make a mark here in northwest quadrant. So going back to the solution, yes, we have this point in southeast within southeast quadrant. That means we plotted this measurement correctly. Now let's use another one. This time I will use a quadrant measurement. Let's make that north 50 west and 20 degrees to the northwest. So as you can see, trend and plunge are in same direction. So this is possible for lines. But for for planar measurements, if you have a northwest strike orientation, which is right here, the possible dip direction cannot be within the same direction, or basically it has to be 90 degrees from this direction. It will be adjacent quadrant. It can be northeast or southwest. For lines, it can be same direction or 108 degrees uh, from that trend orientation. Let's start with this measurement. North 50 west is the trend of this line. Start from north, so it will be in northwest, and we will find 50 degrees of the north. So here 10, 20, 10, 20, 30, 40, 50. We'll mark this point as north 50 northwest. And same with azimuth, because it is plunging northwest, you can move this point to either west or north direction. As long as the direction you move this point is consistent with the plunge direction, that's fine. Don't You shouldn't rotate recent paper and move this point to south or east, because that's not the quadrant it's plunging. So let's rotate tracing paper and move this point to this time let's move it to the west. So you can see, even when you count plunge along equator, you should get to the same point. It is plunging at 20 degrees. So start from perimeter circle, count 20 degrees towards the center. So it's 10, 20 over here. So that's the point for second measurement, plunging 20 degrees. Let's rotate, tracing paper back. Now we can see this point is within northwest quadrant, so that should be correct. Just to make sure we did everything correct, let's move this trend orientation to north direction this time. If you move this point to north, still you see there's a 20-degree plunge between perimeter circle and where we plotted this point. So that's correct. So from west or north, when you count 20 degrees from the perimeter circle towards center, you should get to the same point. So this is how we plot lines. Now we have two lines in two different quadrants.